Okay, so welcome everyone to our first proper session. We're going to be covering two topics really in this session and some smaller topics. So let's have a look at what we're looking at today. So for today's topics then, the topics of the session, we're going to look at something called answer checks and estimates. You might remember this from the initial PowerPoint that we looked at, that question that pops up quite frequently. We're going to have a look through that and just work out and just kind of check how we do that skill. Very important skill, pops up all the time, very easy marks to get there. We're then going to have a look at long multiplication and make sure everyone's got a system for doing this. So today's session is more non-calculator skills than anything. Figured get it out the way nice and early. If you haven't done long multiplication in a while, do not worry. I've got a method that I want to kind of demonstrate to you, which I think is probably the best method to use. We're then going to have a look at long division as well, make sure we've got a system in place for this. And for both of these as well, what I've now added is we're going to be looking at multiplication and division of decimals as well. Very important for level 1 and for level 2, is more popular with level 2 questions now. There's some nice ways around it, and it's just making you aware of what you can do and how you can manipulate these numbers. We then need to have a look at our negative numbers. Make sure that we're all very comfortable, moving across zero. I know there are a lot of kind of common misconceptions remembered from school, with the, two negatives make a positive and things like this. In functional skills, it's more kind of linear problems, so we don't tend to deal with, double negative signs next to each other. So we'll have a look at some examples of that as well. Then we need to have a look at our B.I.D.M.A.S and just remember what this stands for. This is becoming more popular for level 1 and for level 2. But again, the level of questioning that they ask is not very high. It's maybe only 2 or 3 operations in a sum. But it's just remembering, we do this part of the sum first and then this, and it will make sense a little bit later on when we look at that. And then lastly, then we're going to have a look at more of our decimal kind of idea. In regards to decimals, we tend to just kind of be working with money. The main things we need to be able to do, though, is make sure we can order decimals and put the decimals in order of which decimal is largest. Going to have a little bit of a look at the theory then, and then we're going to have a look at rounding decimals as well. Again, this is an underpinning skill that pops up quite a lot of the time. You might find maybe one of those 5 or 6 mark questions that I've mentioned before. One of the marks in there will probably be round your answer to 2 decimal places. If we know how to do that, and it's a very simple method, a very simple thing to do, we're going to get that extra mark there. It's going to really help us just get that extra few marks towards our pass. And then at the end, I will show you where the assessment is on the Google Classroom, and that will be obviously the homework for next session. So if we're having a look at our first topic here then, so if we imagine for a second, we live in the world, but there is one major difference. And that is that Blaise Pascal was never born. Everyone knows who he is, obviously. So Blaise Pascal is the man who's normally accredited with inventing the calculator. So nice French gentleman who invented the calculator for us. So the problem that we have then is if the calculator hasn't ever been invented, you can be sat there in the exam hall and you get asked to kind of check your answer or check the validity of your answer. Like we kind of discussed in the introduction, a lot of people will just say, well, I've done it on the calculator. They might then say, I double checked it on the calculator. And in real life, this is normally sufficient enough. However, you might be doing the wrong sum into the calculator. So it's giving you an answer, but it's not the correct answer for our problem. So if we wanted to check this sum, how do I know what 8 times 3 is? How can I prove what that is going to be? Most of us will just be like, well, it's 24. Absolutely fine. There's a certain way that we want to check these answers, though, and I just want to make sure that we're all very comfortable with how to do this. It does also really help as well in regards to when we use multiplication or division or addition or subtraction. Sometimes it can be hard to pick this information out of out of the question. So knowing about the opposites and how to check answers can be a really, really useful thing there. So the main concept then of checking our answers is based on the idea that everything in maths and in the universe actually has an opposite. Everything has an opposite. We have our adding And again, it's knowing different words for this. I know for people who English might be their second language, knowing all the different words for this can be very, very useful. So obviously we have adding, the total, the sum of, all of these are, just putting numbers together. The opposite of this then is going to be subtracting. So if I'm giving someone something, that is adding. The opposite is I'm taking something away. So, and again, phrase-wise here, we have subtraction, taking away, the difference as well. So the difference between two numbers is always a subtraction sum, although you can solve it with addition. And then we have our other two main operations. Then we have multiplying and the opposite, which is dividing. The main thing to remember is with multiplying, there are a lot of different ways of looking at it. There's multiplying, timesing. Again, the one that I think is the most useful is lots of. All multiplication is constant addition. If I've got 3 lots of 10, I've just got, I've got 10 threes or I've got 3 tens. I'm just adding 10 together 3 times. That's all multiplication is. We've just developed systems with our number system to make it quicker and easier to do these bigger calculations. The opposite there then is going to be dividing, splitting, sharing, this kind of idea. Okay, so this can also be called what's called an inverse function. They normally word it as a reverse calculation though. And we can use this to check our answers. There's a couple of key steps to remember. So the general rules and patterns for this are we always switch the sign in the problem. If we had an addition sum going forward, going backwards, it will be a subtraction. If we had a multiplication, it will become a division. Squaring a number will become a square root. If we're adding, so if our sum was an addition sum, the best thing we can do is try to work right from the end, subtract all the numbers and get back to 0. That's probably the most useful way to do this. This tends to be linked in with when we calculate our means. They might ask us to check our answers. So again, just remember with some of the answer checks, there might be more than one sum, but just start right from the end and go all the way back to the beginning, all the way back to 0. And the last thing to remember is we're always going to have the same numbers, but in a different order, if our answer is correct. So as an example, then, if we have this problem that we looked at, so our 8 times 3 is 24. If I want to check this, I just need to make sure that I'm going to do all of these steps properly. I'm going to switch the sign, so it's going to become a division sign. But again, at this point here, just switching the sign is not enough. This is just a different sum. It gives us an answer of 2.7. It doesn't check anything. What we have to do if we're switching the sign, we also have to start from the end and work backwards. So in this case, we could have 24 divided by 3 is 8. So that is a perfect example of an answer check there. You could also have 24 divided by 8 is 3. Either one, perfectly acceptable. It's just remembering that we are working from the end of our problem, working backwards, and we will always switch the sign over. Okay, so if we can then, let's have a little bit of a go at this. And like I said before, if you want to post your answers directly to me, and then I can kind of check them, make sure that everyone's doing okay, and we'll go from there. So a few questions for you to try then. So what I want you to do is look at these questions and provide an answer check for them. So our first question there, if I've got 24 times 8 is 192, if I asked you to check that, what sum would you do to check it? Remember, we're going to start from the end and we're going to switch the sign, but all the numbers should remain the same. So you can answer all 5 of them if you want in one go and then send your answers over. Probably best to answer 1 or 2 and then send them over. Hey, brilliant. Already got an answer there. Andrea, yeah, you're absolutely fine with this already. Question 1, perfect, yeah. Question 2, absolutely spot on. This doesn't seem like a problem for you. For some people, you might look at this and be like, why am I doing this? This is why I didn't like maths in the first place. I'm just doing random things with numbers. It does actually come in really, really useful for, if we need to check an answer or if we want to pick what type of problem to do. sometimes looking at a problem as a multiplication and seeing a question mark and going, I could do a division here to know what that value is. Stacey, yes, absolutely brilliant. So for number one, yeah, that will work. And the nice thing there is you've actually done the opposite of Andrea. You'll both get the marks for it, but you've divided by one number. Andrea has divided by the other. Sarah, yeah, that's looking absolutely fine. Stacey, that's perfect for the next one as well. Let's have a look at a few more of these then. Let's scroll up a little bit here then. So yeah, so Sarah, I think with that one, that should be 97. Take away the other number there. That's absolutely perfect though. Stacey, that's fine. Lewis, yeah, that's absolutely spot on for the first one. Great stuff. Kathy, they're all correct. Have a look at the last one again though. Just out of interest. Have a bit of a look, see if that sum is actually correct. Okay, great stuff. Everyone seems to be getting the hang of this. They seem quite comfortable with it. What I'm going to do, I'm going to start going through. Sarah, yes, you're one step ahead. You have seen that. And that's actually just an example of like why this can actually be quite useful sometimes. You know, you might have just written that down in your calculations and maybe not shown your workings out. So that's the idea there, to kind of highlight it. Okay, so I'm going to start going through these and just writing down what the answers are then. And then hopefully we can all kind of go from there. But everyone's done absolutely brilliantly so far. So if I show some of these answers, so for our first one, everyone was quite happy with this. We're going to have 192 divided by 8 equals 24. Or again, you could have divided by 24 equals 8. Either way, that's going to be absolutely fine. For our second one, then, we're going to have 6 times 5, and there's only one way to do this. 6 times 5 is going to be equal to 30. You can write the numbers the other way around if you want to. So you could write 5 times 6. Either way, it's the exact same thing. So either way you write that, you will get the same answer there. So that's great. Our addition one here then. So we're going to start with our end. We're going to start with 97. You can, if you want, just take away 15 and say, well, that equals 82. Or you can take away 82 and say that equals 15. You will get the marks for that, not a problem. You are still checking your answer. I would always recommend, though, taking away both numbers. So take away 15 and then take away 82 to get all the way back to 0. Just nitpicking a little bit, but I think that is the best way to do it. Just for sometimes it can be a little bit more useful, but you will get the marks the other way as well, not a problem. Again, the examiners are nice. They do want to give you these marks. For our next one then, our subtraction, it's going to have to be 45 add 60 equals 105. Again, none of these numbers should change if our calculation is correct. So the last point here then is looking at this sum. And again, what we can do is fall into the habit of just writing, well, 105 divided by 6 equals 15. Unfortunately, I know one or two of you have spotted it. This sum isn't actually correct. If I actually do 105 divided by 6, I actually end up with 17.5. So although it is quite easy just to, we're not going to get this in the exam. We're not going to be asked a series of questions on this skill. But I would recommend, if it does ask you to check your answer, definitely do, use the calculator and just make sure that it is actually correct as well. If you're going to have to spend the time rewriting it, you might as well type it back into the calculator or have a little bit of a look at it. So given that this will then be 17.5, we can then reevaluate our sum at the beginning. We can say, well, it's actually 17.5 multiplied by 6 that will give us that answer. Okay, so everyone seems quite happy with that. And again, at any point, if you are a little bit unhappy, if you are a little bit confused with any of the content, please do just pop me a message, let me know. But I think at this point, I'm quite happy to move on from there. We know how to check an answer now. We just do the sum backwards. If you do want to practice any of these skills, as much as I'm going to go through and explain some of this on here, there are going to be extra worksheets available on the Google Classroom. So you can obviously go onto there. If you go, I kind of get it, but I want to practice a little bit more, then obviously you can nip onto there and just practice the other skills there. Okay. So answer checks in the exam then. They tend to word it in one of the following ways. They either tend to say, use a reverse calculation to check your answer, use an estimate to check your answer, or show a check of your answer. In the third case there, you can use either of the above. So if it says use a reverse calculation, then we need to do the sums backwards. And although most of the time, if you do one sum backwards, you will get a mark. I'd recommend doing all of the sums backwards to just guarantee that mark there and to check your own working. If you have to use an estimate, or if at any point you see the word estimate in the exam, all you have to do is change one number and there will be various different answers on the mark scheme. So, if it said use an estimate to work out 12.2 multiplied by 20, you could just say, well, 12.2, that's pretty much 12. And you've simplified the answer a little bit. You might round it all the way to 10 and then, I'm just going to do 10 times 20 then. Either way, you will get the mark. What they want is for you to be able to actually prove that you can use effective maths. So you don't have to work it out to the finest point. You can just simplify your answer. You actually won't gain all of the marks if you complete the sum properly. If it says to use an estimate, you have to make sure that you change at least one number to make your calculation simpler. And again, finally then, so it says show a check of your answer. And that just means you can do either an estimate to check or a reverse calculation, whichever one you prefer. Do be careful though, because in the exam, they usually use a separate box for this. So it will have, your normal question here, and then under it, there'll be a separate box with maybe a little tick on it, and it will say, show a check of your answer, or use a reverse calculation to check your answer. There have been some cases recently though, where you might get the wording of a problem, something similar to this. So it says, give your answer below. You must show your workings. And again, that's, we always show our workings to make sure we get those extra points. Provide a check of your answer. So in here, it's all embedded in the same question. If you see this kind of pop up, the best thing you can do is just, again, make a note of it. Like I was saying in the first kind of video, when we have these kind of 5 or 6 mark questions, we want to go through and bullet point what steps we need to do to get all of those marks. All I say is get your answer, and then under it, just write answer check, and then do the reverse sum. Normally, though, they do give you like the separate boxes, so you should be absolutely fine there. Okay, so that is it for our first topic there. That is answer checking, how we do it. Hopefully everyone's okay with that. From all the answers that you've given, I'm sure you're all fine. So the next thing we need to do then is that really boring part of maths, which used to put everyone to sleep in school, and it seems like the only thing we ever used to do, long multiplication. So we just have to make sure, or I just need to check that we've got a system that works for you. So we need to be able to answer a question, something like this. Normally, 2-digit by 2-digit, maybe 3 digits, so a number in the hundreds multiplied by a 2-digit number. So if you can, what I want you to do is just have a go at trying to work this out. If you've got a system that you used in school, try it, see what you get. If you haven't got a system for it, have a bit of a think, see if you can work it out. And if you're completely lost and you're like, God, I haven't done this in years, I can't remember, do not worry. Just pop me a message and say, I don't know. It's absolutely fine, because I'm going to show you like a foolproof method for how to do this. And it's a really nice method, very visual, really, really helps. I myself, when I was in school, I had one method of solving this where I kind of broke things down in my own way. I then learned this very common method where it's almost like you put one number over the other, and then you multiply, the 3 with the 1, the 3 with the 2, which is a good system. A lot of people use it. If you can do that system and you get in the correct answer, then don't change to my system. If your system works, keep doing it. I just want to kind of show everyone a way of doing this. So I'll just give you a minute then, and I'll stop talking for a second. And yeah, have a go at this one then, and pop me over the answers when you get it, or just pop me over just saying that you don't quite know. Okie dokie. So let's have a look. Then we've got a couple of answers coming in. Oh, fantastic, guys. This is looking very good. Kathy, Stacey, Claire, Andrea. Absolutely brilliant. Yeah, you've all got the correct answer there. Oh, brilliant. And Sarah, that's absolutely amazing. What you've done there is brilliant, because you know exactly how this multiplication works. I'm going to be teaching everyone that method basically, but in a nice visual way. But that's brilliant that you know exactly what you're doing and how it's broken down. Just give it another minute or so then, and then I'll pop the answer up. And again, if you don't know, please don't worry, it's fine. That's why we're doing this course, so I can actually do a bit of teaching. It's kind of boring when everyone already knows it, and you feel a lot better actually learning something as well. So just give you another minute then, and then we'll go from there. Okay, so I think at this point then I'm going to reveal the answer then, or again, you can always use a calculator to check, but obviously we won't do that in our exam. We'll use a reverse calculation. So here then, so the answer that we're looking for is 273. So again, there are lots and lots of different methods for this, and there is no right or wrong way of doing it. So long as in the exam, if you can, if you're given this and you get that answer, you're going to get the mark for it. The method I'm going to show you is quite a visual way of how to do this, and I think it saves on a little bit of confusion. Again, I've looked at this in a lot of different ways. For some people, again, it's writing one number above the other and going through. Some people might use, I know there's it's like a Chinese method where you have a lot of lines and then lines that cross over, and how many vertices there are it's amazing. There's lots and lots of different ways of doing this. I'm just going to show you one method that I think will help and hopefully help you all. To anyone that doesn't understand this yet, help give you an idea of what we're doing. So the method that I prefer then, and the method that I will always teach people, is called the grid method. So if we have a number or a sum like this, 35 times 14, a lot of you that are probably using the method where you have one number above the other, you're doing a grid method, but you're just not showing everything that you're doing. The reason I prefer this method is because you can see each individual sum. It stands out a lot. You can then highlight yourself if there's a mistake in your calculations, where it's come from. The examiner can clearly see it, and it just kind of avoids little silly mistakes. I think sometimes using the normal method can get a little bit confusing when you know, do I carry this number over? Is there a 0 there? So with the grid method then, what we do is we break the sum apart. So we're looking at this and we're saying, okay, well, I've got 35 lots of 14. I don't know my 35 times table, and I can't really be bothered to learn my 14 times table either. So what I'm going to do though is I'm going to break that down into simpler things. I'm going to say, well, 35 is 30 and 5. 14 is 10 and 4. And now what I've got is 4 different numbers. So instead of doing 35 lots of 14, what I'm going to do is I'm going to do 30 lots of 10 and 30 lots of 4. The total will be the same. I'm then going to do 5 lots of 10 and 5 lots of 4. So all I'm doing is I'm taking these two numbers and I'm just breaking them into, you know, how many sums we're going to be doing there. You lay it out in a grid like this. I've got 35 down this side and 14 across here. They can switch and be the other way around. So you could have 14 down here, 10 and 4, or you can have and your 30 and your 5 here, so long as the parts of the same number are in the same column or the same row. So the great thing with this method here is that the biggest calculation you will need to do is up to 9 times 9. You won't need to know anything higher than that. And the nice thing is we're just going to do simple sums and then potentially add zeros. We will look at this idea of adding zeros more when we look at our percentage topic. The reason we're adding zeros is because the actual numbers that we're looking at are 10 times bigger or 100 times bigger in cases. But again, you will get a deeper understanding for this when we look at the percentage kind of topic as well. So I'm just going to complete my grid here then. So I'm going to look at my first number here, and I've got 30 and 10. I'm going to make that simpler. I'm going to ignore the zeros. I'm going to do 3 times 1, which is 3. And then I'm going to add 2 zeros. I'm going to add this 0 back on and this one. Essentially, we take the zeros off, put them back on. The reason being 1 times 3 gives me 3, but actually this was 10 times bigger. So we make, by putting the 0 there, it shifts everything by 1 column, makes it 10 times bigger. And the same here. It wasn't a 3, it was a 30. So we'll just put the zeros back on. Our next one then, so we've got 30 times 4. I'm just going to do 3 times 4, which is 12. And then I'm going to put my 0 back on. The next one then, 5 times 10. I can just do 5 times 1. I've got 1, 5. And then I'm going to add my 0 back on because it wasn't by 1, it was 10 times bigger than that. And then finally, I've got 5 times 4, which is going to give me 20. So now I've done all these individual sums. All I have to do is just add them all together. So I'm going to lay them out in a nice column like this, make sure that everything's kind of in the same kind of space. So you've got your units here, your tens here, and your hundreds here. Or even if we were going into decimals or hundreds, thousands, tens of thousands, make sure you just lay it all out so we know exactly what column everything's going into. We then just do this simple column addition. We've got 0 all the way down there. Then we've got our 2, 5, and 2, which will be 9. And then we've got the 3 and 1, which will be 4. So, hey, brilliant. I've got one message from someone going, that makes so much sense. Brilliant. I'm really, really glad for that, because I worked out a few of my own methods for multiplication when I was in school. And then, it's great them saying, like, oh, just you multiply that, then you do that, then that, then that. But when you actually know why you're doing it, it makes it so much easier to remember. If we know why we're doing these simpler sums, really for the functional skills course, we only need to remember 1 or 2 formulas, and that's about it. So it should hopefully be helpful. So what I'm going to do then is put up some practice questions for us, so we can have a go at this. And what I'll do is I'll actually work through the first question and just show you how this can actually, how this grid can work. It will work as well if you bear in mind if we have bigger numbers, and I'll do a quick example of that in a second. But if you can all try these sums here then, if you haven't had a method before or you want to try the new method, use it. If you're like, no, you know what, I'm going to stick to my method, I know that it works, then by all means, stick to your own method. I just want everyone to have something that they can use. So in this case here, then, I'm just going to do a worked example for this first one. So feel free to obviously work along at your own pace. I'm going to break these numbers down. I've got 26 and I've got 13. So I'm going to have 20 and 6. And then I've got 10. I've got 3. So then all I'm going to do is just multiply each of my numbers here. I've got my 1 and my 2, which will be, well, 1 times 2 is 2. But I'm going to add my 2 zeros back on there. And again, the mathematical reason why we do that is because they are both 10 times bigger than the numbers we multiplied. 10 and 6 is going to be a nice solid 60 there. 3 times 2 is going to be 6 with our extra 0. And 3 times 6. And again, if you don't know, most people tend to struggle with the 6s, the 7s, and the 8s in regards to the multiplication tables. If you don't know them, I'm not one of those people that can, if someone goes, oh, what's like 7 times 6? I don't know off the top of my head, but we know that multiplication is constant addition. I'm just going to write down and just add 7s together until I've done it 6 times, and it'll be fine. So with 6 times 3 then, this is going to be 18. We've done all of our sums, and we're just going to group that all together. Again, normally you'd lay it out in a column. I'm not going to do that because it just takes a little bit longer drawing with my mouse. So I'm going to do a bit of a shortcut and say, well, these two here are 120. I'm going to add that on there. So I've got 320. And then I'm going to add my 18. So in total, then I'm going to have 338, I hope. If anyone's got a different answer, do let me know, because I'm only human. I might make mistakes. But we should have 338 there. So there's a worked example for you. If these were bigger numbers, just as an example, let's say I've got 121 multiplied by, I don't know, 15. I'm not going to work all this out, but I just want to show you that the grid will be the exact same. It just gets a little bit bigger. So I've still got my 10 and my 5 for 15, not a problem. But now I've got 100 and 21. I've just got an extra sum there. So all I'm going to do in this case, instead of doing 4 sums, I'm going to do 6, and then I'm going to add them all together. So just a little example there of how this works with even bigger numbers as well. Normally, we don't need to worry too much about these over functional skills. Okay, so let's have a look at some of these answers then. Okay, so Andrea, you agree with me for the first one then? I'm very happy with that. Let me just check your second one. Second answer is absolutely fine as well. And the third one is absolutely perfect. So I'm assuming whatever method you're using, it's working. Stick with it. So Sarah, that one's gone a little bit off there. Again, it might be the method that you're using. It might just be causing a little bit of confusion. Have a look at it, maybe give it another go, and see what happens with it. Stacey, absolutely awesome. Yeah, yeah, they're all absolutely spot on there. So, are you using this grid method now, or have you got a different method out of interest?
No, I'm using your method. That makes it so easy. I can't believe it.
Oh,
Yeah,
brilliant.
brilliant. Yeah,
Did you have a different method before?
well, just the numbers on top of each other and then times it. And I was getting all confused, but makes it so easy doing it like that.
Oh, brilliant.
That's brilliant.
Yeah, that's one of the things that I found when I was kind of trying to teach it to people. One of the issues that it invites, especially in some of the schools I was working in, is they introduce this kind of like a magic zero.
Yeah.
And for a lot of the learners, they didn't know why these zeros were appearing. And it causes problems further down the line when you look at place value. When we look at decimals, it can be a little bit confusing. Yeah. The same with multiplying and dividing by 10. So yeah, really glad that
that's brilliant. That's a really good way of learning it.
Oh, fantastic. I'm buzzing for you. Yes, we've achieved something in the first proper session. Okay, so what else have we got there? So yeah, so Sarah, sorry, you're for question 3, that's absolutely spot on. So it might have just been a little miscalculation for number 2. Yeah, there you go. That's spot on for it. Have you got your own method as well, or are you using this grid? No problem, no problem. Whatever you're doing, you're getting the right answer, so stick with it. Claire, yeah, they're both absolutely spot on as well. Okay, so we'll just leave it up for just another minute or so. Oh, cool, Sarah, fantastic. And again, if you knew about the grid method before, that's great. If not, and it is one of those things, I know practicing multiplications can be a bit tedious. If you are switching to using this kind of grid method, I'd probably recommend on the classroom, maybe just do one of the worksheets. There's maybe 10 sums on there, 15 sums on there, and they have all the answers on the back. So you can just practice drawing out the grid. And again, it feels quite nice when you actually, if you remember multiplication in school being a bit of an issue, now having a system that works can, really, really boost your own confidence as well. And yeah, Sarah, absolutely fine. It happens sometimes, put the wrong number here or wrong number there. What we now know though is, if we needed to, we could check the answer. We could, if we're maybe happier with long division, we can just kind of check our answer with division. So I'll just give you guys another minute or so on this, and then we'll get moving on. Again, you can always, obviously, if you're watching this recording, you can always just pause it and have a go in your own time. And again, we can always come back to these sums as well at a later point. Kathy, yes, absolutely spot on. They are both perfect. Again, like I mentioned before as well, if you don't really want to submit your answers over, absolutely fine. Maybe just pop me a message and say, I've finished, can we move on? Or or again, if you don't want to submit your answers, it's absolutely fine. Don't worry. It just helps me keep my pace a little bit better. Okay, so most people have done really well there. I'm already amazingly happy at the fact that someone's obviously now a lot more comfortable with this skill. So that's an absolute winner. So the answers here then, we should have 338, 270, and 984 then as our answers there. So if you've got them, amazing. If you haven't quite got them right, don't worry. We can practice this skill. It'll be absolutely fine. Do bear in mind that for this as well, so for these kind of calculations, 75% of the marks for our exam are on the calculator paper. So you'll always have a calculator there. Only 25% of the marks are on the non-calculator, which is where this type of skill might come in. So if you struggle with this, it's not the end of the world. So the other thing we need to look at, and this is becoming very, very common, especially on level 2, is the idea of multiplying with decimals. Most people quite happy with multiplying with whole numbers and quite happy with the idea of maybe multiplying with these bigger numbers now. But when we start looking at decimals, people get a little bit confused, and it causes a little bit of anxiety there. You know, I've got 8 lots of 0.7. I can work that out if I change the wording of it. You know, instead of times or multiply, if I say I've got 8 lots of 0.7, I could just add it together. You know, just 0.7, add 0.7, add 0.7. It might just take a little while. So what we're going to do here then is a bit of a shortcut. And the best way to do this is if you have any decimals involved at all, ignore them. So here, instead of doing 8 times 0.7, I'm going to ignore that 0 point, and I'm just going to work out 8 times 7. Okay. If you don't know your 8 and your 7 times table, again, don't worry. Add it up down the side of your page. But when I do 8 times 7, I get 56. The great thing with this is I know that my answer is going to have those digits in it. I just need to make sure that I put the decimal point back in the right place. The more mathematical way of looking at this is realizing what we've changed. So instead of doing 0.7, we used 7. So that means that our answer is going to be 10 times too big. So that means that 56 is 10 times too big. So I'm going to divide it by 10 to make it 10 times smaller. If that doesn't make sense, please don't worry. We're going to look at multiplying and dividing by tens, hundreds, and thousands in our percentage lesson. It is a very, very useful skill to be good at because it helps us with switching between measurements, so like centimeters to meters, etc. And it also is very, very useful for fractions and percentages. It's a very, very nice skill to know. So that's one way of looking at it. You know, okay, well, I've got 8 times 0.7. I'm going to ignore the decimal place and just do times 7. And then I've just got to remember, okay, well, I've just made that number 10 times bigger. I'll make my answer 10 times smaller, and you're perfect. The other way that most people find this a bit easier is just use an estimate. You know, if I look at that, so right, I've got 8 times 7 is 56. What would an estimate of my answer here be? Okay, well, I've got 8 times 0.7. 8 times 0.7, 0.7, it's pretty much 1. Yeah, if we call that 1, 8 times 1, my answer is going to therefore be around 8. And that just tells me where I can put my decimal point back in. In this case here, I've got my answer of 56, which I know is too big. My decimal point's either going to go here or it's going to go here. If I put my decimal point here and I have 0.56, I know my answer is way too small because my answer's got to be close to 8. So just use an estimate and put the point in there. Hopefully that helps then. So in regards to these kind of multiplications with decimals, this is the way that we're going to do it. We can still use our grid method, absolutely fine. We are just going to ignore the decimal places, get the right digits, and then put the point back in after. It's the easiest and simplest way to do it. So if I give you another example then, so something like this, which is where it looks a little bit more horrible. And again, this popped up on one of the non-calculator papers recently, and this was worth 3 marks. So that being said, you know, a question like this, it's very, very useful to just be confident in our multiplying ability. All I'm going to do, right, I've got 8.3 and 3.4. I'm going to just ignore the decimal points. So all I've got here is 83 times 34. I can work this out using the grid method. So I put my 80 and my 3, my 30 and my 4, put my grid in, and I'm going to get an answer of 2,822. Now, again, all I have to do now is work out where my decimal point is going to go. Technically, what we've done, mathematically speaking, 83 is 10 times bigger than 8.3. So our answer is 10 times too big. 3.4 is 10 times smaller than 34, which we used in our sum. So again, that is 10 times smaller. Overall, we need to make our answer 10 times smaller and 10 times smaller. So in total, 100 times smaller because our answer is 100 times too big. So all I'm going to do then is 2822 divided by 100, and that will give me my answer here. Again, if that's a little bit confusing, don't worry. I'm sure it'll make more sense as we progress through the course and we'll recap these skills. The other way use an estimate. Okay, I've got 8.3 times 3.4. It's roughly 8 times 3. So I know that 8 times 3 is 24. I can work that out. So I know that my decimal point needs to go in the place where I'm closest to this answer. It can't go before the 8 and make it 2.822 because that is way too small. It can't go on the other side so that we end up with 282 because it's way too big. The closest it can be to that estimate is to put the point right in the middle there. So I hope that's okay with everyone in regards to how this works. It was something that was causing a lot of confusion before, which is again why I've added it to this PowerPoint. So there's a couple of practice questions here for you. We're not going to go through all of these. We're not going to spend an excessive amount of time, but these are here complete with the answers for you if you want to work through the PowerPoint in your own time. What I'm going to do is maybe give people a few minutes, just try maybe the first one, maybe the second one, or just pick one or two that you like the look of. Have a go at the answers, pop the answers over to me, let me know how you're doing with them. And then we'll move on from there. But we're not going to do all of them, but I will load up all of the answers in a second if you want to check. Just let me know how you get on. Okay, brilliant. We've got a couple of answers coming in then. Oh, very, very close here. So, Sarah, the main thing here is that the decimal point's in the right place. The number's a little bit off. Your answer is 0.06 too small. So it might have just been a slight miscalculation. The main thing, though, is that you've got the point in the right place, so you understand how this will work. Claire, absolutely brilliant. Yeah. Andrea, that's great for number one. Haven't checked number two yet. Let me have a look. I'll check that for you. So 4.8. And yeah, that's great for number two as well. So you seem to have a good understanding there. Stacey, your answer there, and number one was a bit of a, again, it's a bit of a strange one because we didn't look at that as an example. Your answer is actually still 10 times too big. So if you think about it, your numbers are fine, the value that you have, but the decimal point needs to be one place to the left.
Oh, okay.
I don't want to give the answer away for everyone, but
yeah, no, okay.
Yeah,
this is all new to me. It's so long ago since I did all this. So
no problem. Don't worry about it. It takes a little bit of, practice makes permanent. So the main thing to make sure that is that we're practicing the right thing.
Yeah.
If not, you remember bad habits. I remember one of the worst things I had in school is you know, them giving you a whole page of 50 multiplication sums,
Yeah.
I get 25 through, and then they go, oh, they're all wrong. I'm like, oh, brilliant.
Yeah.
Now I've got to unlearn that and relearn this.
Yeah.
But no, it's absolutely fine. It's just with that first one, it's just a little bit more difficult because the 0.47 is becoming 47.
Yeah.
It's just remembering that it's essentially jumped twice, but even there, like using an estimate can be a bit difficult because then it's like, well, I've got a half times 6, which can be a little bit confusing. But
oh gosh, yeah.
have a go at the next one though.
Yeah, we'll do.
Yeah, I'm sure you'll be
Okay.
fine with it.
Okay.
So Andrea, that one's looking good for. Yeah. Oh, having a go at the harder one as well. Let me double check that one for you. Definitely. So you've got 9.6 multiplied by 0.09. And yes, you're absolutely spot on. That's brilliant. Again, it's some of the sums like that where it is harder to use an estimate. But again, you still can. You can kind of look at it and go, well, 9.6, I'm multiplying it by a number that small. It's almost like the same number. It can be a little bit confusing when you get to these smaller numbers, which is why kind of knowing like that you're multiplying by 10 or 100 or 1,000 can be a bit more useful. But the estimate is a good method to kind of start with. Sarah, yeah, that's absolutely spot on for number 1. Great stuff. Kathy, that first one's looking spot on. I'll double check some of the other ones for you very quickly. Number 2 is a little bit off. I think the point's in the right place, but the numbers are a little bit off there. So it might just be a slight miscalculation. Again, do remember that even if you do get a miscalculation, it's not the end of the world. If you've got the decimal point in the right place there, you're going to get at least 1 or 2 of the marks here. There's also carry-on marks. So if you get a slight miscalculation at the beginning, you can still get the further marks. So don't worry too much about it. Yeah, question C though is perfect there. So absolutely spot on. I'll just double check so Sarah and Stacey, if I just double check that one for you, and I think you are both correct. Yeah, so for number 2, you're both absolutely spot on there. So we've all had a little bit of a go of at these ends. So what I'm going to do, I'm just going to pop up the answers now so everyone can have a bit of a look. Oh, God, that jumped a bit, didn't it? Okay, so I've just put up, so these are all the exact same sums, but now obviously we've got the answers kind of there as well. So you can obviously have a bit of a look on the ones that you're working through and just double check. Most people are doing absolutely great with this, so there's no problems there. If you are finding like, you know what, I could do with spending a little bit more time on this. Again, there's plenty of time for it. You can rewatch this, like this presentation. You can rewatch the actual video of this presentation, and there's practice worksheets. So don't worry. This is a bit of a strange unit to cover because we have to look at multiplication, division, negative numbers. There's a lot of different things. With some of the other topics, it's a bit more linear. So when we look at fractions or percentages, we tend to start with a concept and build on it, and like build on it. Whereas here, we just have to look at a few different skills and check that we've got them. So if you do feel a little bit overwhelmed, don't worry, take a breather. You've got all week to just kind of recap it and have a look again. So I'm hoping everyone's doing okay there then. Most of the answers that were coming in were absolutely fine. And again, the most important thing for me was that I don't think anyone put the decimal point really in the wrong place. It was mainly just kind of slight miscalculations. So that's absolutely great. And again, for a lot of us, we haven't done this in a while, so no problems. What we now need to have a look at then is long division. So we're going to take multiplication and pop them over there for the minute. We need to have a look at long division and make sure we've got a method for this. So without a calculator, would you be able to produce an answer for this question? And again, if you haven't got a system that works for it, do not worry, it's absolutely fine. We are going to go through and we're going to work through a fair few of these examples and make sure that everyone's okay. Out of interest, can everyone still see the questions there and not the emails that have loaded up?
Yeah.
Okay, that's great. I just didn't want to have like all these emails that have just popped up. It's just got another learner who's wanting to join and having some problems. So send that. Okay, so for this one then, you might get some different answers. Some people might know this with remainders and things like that. The answer that we're looking for here then is going to be 31 remainder free or 31.5. Normally, this is it's always better to go into decimals. So we'd have 31.5, for instance. There are some kind of cases where you might be asked, if someone's sharing out apples for some reason, it might be a case of then like, okay, well, how many are left over? If we're asked that, then obviously we can just work it out. But 9 times out of 10, or most common, even more than that, it's going to be working into decimals. So if you've got a system for this and you've got that answer, amazing. If you haven't, don't worry. We're going to go through and work through quite a few of these and just going to show kind of clearly how it works. So what we're going to use then is something called the bus stop method. And this is the most common way that we use for calculating long division. Some people do show it in different ways. I was working with some Ukrainian learners recently, and they use a similar system, but it's laid out a little bit different. So long as you're getting the right answers, absolutely fine. Stick with what you're doing. Basically, how it works is it uses inverse functions. It uses our reverse calculations. So what we're essentially doing is kind of flipping it over and using multiplication to work out division. There's a few little things to remember, but in general, it's quite straightforward. So if I give you a bit of an example, and then we can try a few ourselves. So if we have a sum like this, so we have 159 divided by 3, what we can do and what we know, and one way of solving this is to think, okay, well, 159 divided by 3 equals something. Therefore, I can do the inverse. I can do the opposite. Something multiplied by 3 is 159. So I could just count up in threes, and that's how I used to do division before I knew this method. I'd say, well, I've got 10 lots of 3 would be 30. That's too small. Okay, so 20 lots would be 60. It will work, but when you end up going into decimals, it gets very confusing. So the way that we lay this out then is we want to know, well, how many times does 3 fit in to 159? So what we do is we draw our number here, and then we have our number here. So the number that we're dividing by goes on the outside. So we've got how many times does 3 go into 159, and then we just look at each number and can it fit in there? And we treat each number as its own digit to make this work. So first of all, it's, well, how many times does 3 fit into 1? Well, it doesn't. If you've got a size 3 foot and you're trying to get into a size 1 shoe, it's not going to happen, or it might be, but it's going to be very uncomfortable. So 3's into 1 doesn't work. So that's going to be 0 with remainder 1. So what I do is I put the 0 up there, and the 1 carries over to the next column. The important thing to realize here, and this is one of the areas where people tend to make some mistakes, when the 1 carries over, it doesn't make that 5 become a 6. Because it's come from a bigger column, obviously, in our number system, the column on the left is always 10 times greater. So that 1 there has moved over, making our number 15. because that value is 10 times bigger than that 5. So we just need to remember the number carries over and it goes in front of that value. So now we have 3's into 15. So again, I can just count that up and I'll use multiplication, 3, 6, 9, 12, 15. Okay. It's going to go in 5 times, absolutely perfectly. And then I just look at my last number. How many times does 3 go into 9? Well, that's going to go in 3 times. So this is the system that we can use. I'll put up another example and we'll work for a few more of these and we can see how it works with decimals as well. But generally, it's always the same method. It always works the same no matter what. So here's another example here then for you. This one's kind of demonstrates that you might have more than one that is carried over. So if you have 2 remainder or 3 remainder, you can obviously do that. I'll give you guys just a second to answer this one, and then I think I'll go through and just kind of demo, like demonstrate the other kind of variations, just to show it's the same thing. But have a quick go at this one. Pop me over your answers when you got them, and we'll go from there. Sarah, that one's a little bit small, the answer there. You should have an answer that is for 11 more than that. Might have been with the carrying over at some point. But again, don't worry about it. We're going to look through more of these examples. Claire, that's absolutely brilliant. Yeah. Andrea, that's great as well. Kathy, yeah, brilliant. Okay, I'll wait for just one more answer to come in and then I'll start kind of talking through it. We can have a go at some practice questions in a little while as well. Okay, any other answers there? Okay, so we'll get moving on then. So, oh, there you go. There's an answer. Oh, okay, brilliant. Yeah, Sarah, that's absolutely spot on. So, with this one, then, what we're going to have is we've got our 285. We put them in the bus stop there, and then we've got our 5 next to it. So the first step then. Stacey, don't worry, I'm going to keep going through different examples, so you'll be able to catch up. So no problem at all there.
Thank you. Sorry, my daughter rang me and it came up on my computer and the screen disappeared. So
it happens. Don't worry about it.
I'll just watch you now do it and I'll get it. So sorry.
No, it's all good. It's all good. So with this answer, we've got 285 divided by 5. Essentially, what I'm doing is I'm using reverse calculation. I'm saying, well, how many times does 5 fit into this number? So first of all, then, does 5 fit into 2? No, it doesn't. It's too big. So we've got our 2 remainder there. So we're just going to put our 0 up there. The 2 goes into the next column. It doesn't make the 8 become a 10. It makes the value become 28, because anything in the column to the left is 10 times larger than the column to the right. So it goes in front of it, and that's the value that we now have. So now we look and we say, well, how many times does 5 go into 28? We can write our 5 times table down the side there. And we're going to find out that, 5 goes into 28 5 times, and there's 3 left over. So that 3 left over is going to move to the column to the right. and our number 5, our 5 lots of whole numbers, goes on top. So finally then we're going to have 5 times 35, or how many times does 5 go into 35, sorry, and that's going to be 7 there. So our answer is going to be 57. Most people seem very, very happy with this as an explanation. And there is some extra resource on the classroom which will explain exactly why this happens. I don't tend to teach it because it causes more confusion. Most people are very happy with, okay, how many times it fit into that number? If it doesn't, I'll carry it over. And it's all about multiplication, essentially. So let's have a look at another example then. So this one here is just to demonstrate that this will also work with 2-digit numbers. There's no difference. So in this case, I've got 288 and I'm dividing it by 12. I'm going to do the exact same thing. Does 12 fit into 2? No, it doesn't. It's too large. So the 0 goes on top, the 2 carries to the next column. I then look here, how many times does 12 go into 28? Well, it's going to go in 2 times with 4 remaining. And then finally, how many times does 12 go into 48? And that's going to give me 4. So, and again, you can always check this answer. 12 times 24, does it equal 288? If so, you've done it right. So this answer checker, knowing how these are linked between multiplication and division, is very, very useful for us. So yeah, dividing with a 2-digit number, you might just have a few more numbers carried over. You know, sometimes you might have 10 remaining or something to that effect. And you do it in the same way. You know, if I had 10 remaining, I'd put the 10 up there, maybe the 8 afterwards, and then I'd have 108. So sometimes you just have to add up to slightly bigger numbers, but it's still the exact same concept there. This will also work the same if we have a decimal and we're dividing by a whole number. Exact same concept. It's nothing different. What you can also do is kind of just ignore the decimal point if you want to. It gets a little bit more complicated at that point, and we'll address that in a moment. But if we're just saying, well, how many times does 4 fit into 5.44? We can look at it the same way because our number system is all based on tens in different columns getting larger. So 4's into 5, that's going to be 1, and we've got 1 left over. And again, just to demonstrate here, the 1 moves over in front of the next number as if the decimal point wasn't there, but we know it is there. Then we have 4's into 14. Okay, that's going to go in 3 times with the 2 remainder, which moves over again. And then we have 4's into 24, and that's going to give us 6. So in this example, no problems either. We are just doing the exact same thing. The fact there's a decimal point there doesn't change anything. All of our numbers always get 10 times bigger in those columns. So the last really example that we need to look at is, well, what if it doesn't fit in perfectly? So in this case, we know straight away that 27 divided by 5 is not going to be a whole number. So just to demonstrate how this will work, we have, well, how many times does 5 go into 2? It's not going to happen. Our 2 remainder then moves over. Okay, 5's into 27. It's going to fit in 5 times, but we've got 2 remainder. This is one of the important bits. It's just to remember that obviously, like we had before, that 2 that is remaining is going to go in front of the next digit. The next digit here is actually, if we look at this in terms of maybe money, if we've got £27, you know, you've got as a point after that, and you've got an infinite amount of zeros really, but you've got 27.00. You've got £27, no pence. So that decimal point is always at the end of the number. We just don't put it in if it's not relevant. We are lazy as mathematicians. In this case, we've got our 2 remainder. As we can see there, it's going to go in front of it like this. So we've got our 0.0 and the 2 goes in front of it. Just like we've done before, the number that carries over always goes in front of that number, even if it's a 0. And then finally, then 5's into 20. We're going to end up with 4 there. One more example here then, because it can go more than one step. So 34 divided by 8. In this case here, we're going to have, well, how many times does 8 go into 3? It doesn't fit. So I've got 0 with 3 remainder. How many times does 8 go into 34? It goes in 4 times with 2 remainder. So 4 there. Our remaining 2 goes in front of our 0 here. And again, this is repeat. So 8's into 20, it doesn't quite fit. It goes in twice and there is 4 remaining. The same thing happens. There's another 0 after that 0. We just don't put it in because there's nothing there. We don't need it there. In this case, we now do need it there because we need to work out exactly what number we're dealing with. So then we have 8's into 40, and that is going to give us our 5 there. Okay, I hope that's okay with everyone. I'm just going to have a quick check of the time and make sure that we are on schedule. Okay, we're doing well here. What I'm going to say at this point is we're going to put a pin in division here. If you want to practice this, then you're going to have to come back onto the presentation and have a look through. Unfortunately, we've got a few other topics that we need to kind of cover first of all. What we can always do is, if we've got time at the end of the session, we can review these. And as always, if you have any questions or you want any extra resources, just pop me over a message and we can obviously address it there. I just think it's better that we cover all of the content that we need to, instead of kind of staying focused on certain questions. But if you have a look at this PowerPoint, we've got all these questions here to practice on, and they've all got the answers there as well. Again, like I said earlier, this is a bit of a strange topic because it's a lot of different topics which are smaller at the same time. So it looks like we're just kind of jumping all around. If you get a little bit confused or anything like that, do not worry. Just rewatch it another time and I'm sure you'll be absolutely fine. So the thing that we need to have a look at then is, like we looked at when we looked at multiplying with decimals, we need to look at, well, how do we divide with decimals then? We looked at one example there, and we looked at dividing into decimals when our numbers don't fit perfectly. But there's a bit of a trick to this, which makes it a lot easier than actual multiplication as well. But again, we need to understand why. If I had a sum like this, so 420 divided by 70, I can work that out using my bus stop. I can say, well, how many times does 70 go into 4, into 42, into 420? I'm just going to have to count up. I can tell you the answer there is going to be 6. If I have this sum here, then what you'll find is that the answer is the exact same. So 420 divided by 70 is 6. 42 divided by 7 is also 6. This pattern will continue. As we can see here, I've now got 4.2 divided by 7. The answer, still 6. If I make them both smaller again, 0.42 divided by 0.07, it's still 6. It can be a little bit confusing because some people, when you're looking at those smaller numbers and you think, well, division numbers get smaller, how has that got bigger? Remembering this the other way round is a good way of looking at it. With 0.42 divided by 0.07, we're also saying, well, how many 0.07s fit into 42? 6. So what's happening here then, and this is the key point with our division, because we have, so with our top question, we have 420 divided by 70 is 6. What we've then done is we've reduced the amount that we have by 10 times. We had 420 bouncy balls, and we've divided it by 10, and now we've only got 42. At the same time, instead of sharing those 420 bouncy balls with 70 people, we're reducing that by 10, and we're only sharing it with 7. So we have the same sum. This kind of concept is, when we start looking at fractions, is very, very useful. But it's also just to kind of show this kind of proportion. If I've got, this many of something and I'm sharing it with this many kind of people, if I reduce how much I'm sharing it, let's say I could half it as well if I wanted to. 420, if I halved that and I got 210 and I halved this amount, I halved the amount of people, I've got half as much of the thing I've got, but I also have half as many people. the answer will still be 6. So it's an advantage to us then, because we know that we can increase the quantities by the same amount or decrease them. It can make some of these horrible looking decimals look very, very nice. Something like this. So 17.1 divided by 0.3. It looks horrible. And again, this skill will become easier when we look at our percentage module and we look at our multiplying and dividing by 10. What I can do here though is I can just say, well, okay, instead of 17.1, I'm going to call that 171. I'm going to say instead of 0.3, I'm going to say divided by 3. What I've done is I've increased this amount by 10, and I've increased the amount I'm sharing it by 10. It is equivalent. It is the same thing. So 171 divided by 3, I can put that in my bus stop, and I'll end up with the correct answer there. The thing to remember is there's a bit of a difference. When we multiply with decimals, if I make this number bigger and this number bigger, we're dealing with lots of, it's constant addition. So if I make this number 10 times bigger and this number 10 times bigger, my answer is 100 times too big. When we're dividing, because we're sharing things, if we have more of that thing to share and more people to share it with, it is balanced. It's still the exact same. So when we multiply, we have this extra step where we have to reduce the number at the end. When we're dividing, we don't have to do that extra step if we've increased them in proportion at the same thing. Normally it'll be with 10. You can also, with this one, you might double the number on the left, so double the number on the right. You could times it by 5, by 6, anything you want to, so long as you do the same to both sides. So again, there are some practice questions here for it. So if you do want to kind of have a look through this and practice this skill, there will be some time to do that. At the moment, though, I think it is more important that, again, we kind of move on and we have a look at the other topics and really get our heads around that, because it's a bit more important, I think. But again, here are some practice questions. They do have the answers attached as well. So I definitely recommend over the next week, revisit this, make sure that you're very comfortable with it. And again, when we complete our weekly assessment, questions like this will pop up to just kind of test that ability. So we need to have a very quick look at negative numbers and just make sure that everyone is okay with this idea of working across zero. It's a very common, a lot of very common mistakes can occur here. Some really useful ways of looking at it though. So the best way to look at these types of problems is to just think, is the total becoming more positive or more negative? Drawing a number line is a very, very good way to visually see this. So if you're dealing with a negative number and you're becoming more positive, you can see this quite clearly. You can almost draw a little jump there. I would always say, if it's tricky, draw a picky. It really, really helps to have that visual kind of aid to help you. Imagining something like a thermometer can be really, really useful as well. So if it's -3 degrees and it gets 5 degrees colder, what is the temperature? Thinking about temperature is always a good way to imagine this, but again, I can use my number line here. Well, I know it's -3 and it's getting 5 degrees colder. So I'm going to end up, I'm becoming more negative. I'm going to end up at -8. If this was written out, it would just be -3, -3, take away 5 or -5. Just think to yourself, is it becoming more negative? It can be a little bit confusing, so that's why I just wanted to make sure that we're all very clear on this. The other thing that always works is thinking about this in terms of money. So our answer there is going to be -8. If we look on this side, if we imagine a money problem, so let's say if you are £6 in your overdraft, which I hope you're not, but some of us are, and you spend another £4, then how much money do you have? Again, look at it on, imagine it as a time, a number line, or imagine it maybe as a temperature, or it's -6 and it's getting 4 degrees colder. The actual sum we have is -6 and we're taking away 4 more. We are becoming more negative. So in the end, we will end up at -10 there. It's a very common, it's more common this type of question on level 1 papers, to be honest. A very nice straightforward question. Can be on level 2 as well, and we just need to be comfortable with these negative numbers. So I've got a few practice ones here for you, and we will do these ones because we do need to make sure we practice a little bit. With the others, I've given you more examples. I would like us all to have a go at some of these and see what answers we get. So if we have a look through, just imagine again, like you're minus £3 in your bank account and you lend someone another £1. Or it's minus 3 degrees, it gets 1 degree colder. So have a quick go at some of these, pop your answers across, and then we will go through them in just a second. I'm liking this, got loads of answers flying in already. Okay, so Sarah, first one's absolutely perfect, second one's absolutely perfect. Yeah, for some people, this will be very easy and you'll just fly through it. For other people, it does cause a little bit of confusion, which is just why I want to make sure that it's addressed. Andrea, yeah, that's absolutely perfect for you as well. And the next two are fine as well. So everyone seems really quite happy with this, which is brilliant. Yes, Lewis, absolutely spot on for that first one. That's great, mate. And yeah, for number 2 as well. That's brilliant. Stacey, yeah, that's looking absolutely fine. And yeah, Lewis, that other answer there is spot on as well. It may seem like sometimes like you look at some of these and you think, oh, what? That's easy. Of course, everyone knows that. Certain things, some people might have forgotten in school, or they might have not been there for that lesson. There's a lot of little things like that, in all fairness. In what you'll tend to find as well is that you will find certain types of maths easier than others. It's a really useful thing to highlight that as well. Don't just think about the areas that you need to improve on, or the things that you're not very good at. Have a look at the areas that you are very good at and think, well, I'm going to get most of those marks there. You can also use that knowledge to help you with others. The nice thing is as well, where everyone's different, everyone's going to be different, like kind of better at different things. This is looking absolutely brilliant, guys. I don't think we need to look at any more of this. So I'm just going to put up the answers because I think everyone's absolutely fine with this. So we should have -4 here, so -3, and it gets 1 degree colder, -4. If it's 6 degrees and it gets 8 degrees colder, -2. If I imagine I'm at -5 on my number line and I'm adding 6, I'm becoming more positive. It's going to take me 5 to get to 0 and then 1 to add on. So that kind of number line idea can be very useful if we're dealing with time problems as well. 4 take away 2, 2. -3, add 1, so we're at -3 degrees. It's getting 1 degree warmer. I've got £12, but I accidentally spend £15 on a takeaway. Nice vindaloo with some chicken tikka starter, and oh, definitely getting a curry later. So 12 take away 15 is going to be -3, and then finally -3 -6 is going to be -9. I don't think anyone made any mistakes with that at all, which is absolutely brilliant. So that is another topic done. So absolutely brilliant stuff there, guys. Well done. Just need to make sure that we're all very comfortable with that. So I hope that's helped. And again, practice worksheets are on the classroom if you want to. Obviously, if that's a skill that you think, you know what, I'll brush up on it a little bit, have a look on the classroom. What we've then got then is our what's called B.I.D.M.A.S. Some people will know it as B.I.D.M.A.S. B.I.D.M.A.S is one as well. It's all the same man with a different hat. It's our mathematical language. It tells us the order in which to do things. It causes a little bit of confusion because it's with most maths that we do, we work from left to right, the same as how we read. We read from left to right. in reality, we don't actually do that. 90% of your questions that you'll get for functional skills, you won't need any B.I.D.M.A.S. We always apply B.I.D.M.A.S, but because of the style of questioning, you won't need it, because you're going to read a question and you know that, well, first of all, I need to know how many tiles has he got. Then I need to know what's the area of the roof. Then I need to do this. So the sums themselves are written differently. On the non-calculator paper, though, this has been popping up more, and they have been kind of putting these always like slight kind of linear problems on here. So we just need to know what is the order that we do things. We have this order and we follow this order to keep everything unified. The reason being, again, if I had like a certain question as an example, so let's say 25 add 5 times 2. If you complete this sum from left to right, you get an answer of 60. If you complete this sum following B.I.D.M.A.S, what you're actually doing is you will do the multiplication first. So you'll do 5 times 2, which is 10, and then you will do your addition after. So as you can see, although there's two different ways of essentially looking at this sum. I can do 5 times 2 add 25, or 25 add 5 times 2. They look like they should give you the same answer. If you go from left to right, you will get different answers. If you imagine if you're working in like another position where there's a lot of maths that you're dealing with, or if you're working in the scientific community, if let's say there's someone in France, he's written down all of his calculations, he then sends them off to a co-partner in Germany. If they just read it from left to right, our friend in France might have written his sums down in a different order, but he's meant it in one way. Instead of having this complication of having to rewrite it in the same order as everyone else, we always use B.I.D.M.A.S to clearly show what bit we're going to do first. Again, for us, for functional skills, it is becoming more of a kind of thing that they're asking us about. It tends to be a small marked question on the non-calculator paper. The main kind of issue that you can find with this as well is some calculators, if you have an older calculator, or maybe even an older phone, your phone or your calculator will do the sums from left to right. If you have one of these, like a scientific calculator, it will follow B.I.D.M.A.S, which is great, but in some cases it can actually give us an incorrect answer. An example of this is when we are calculating the mean for our statistics. What we do is we add all the numbers together and then we divide by how many numbers there are. If you have a calculator like this, what it will do, or like or a newer decent kind of phone, what it will do is if you type in all these numbers adding and then divided by 5, it will do the last number divided by 5 and then add it all together, which is the correct way to do it. It is the mathematically correct way. It follows B.I.D.M.A.S, but it will give you the wrong answer. Sounds like a lot of talking. I do apologize. The main kind of point here is that we always follow these steps. We always do our brackets first, and we're going to look at what they are and how they work in just a second. Then we do our indices. That's not just somewhere where the pirates sail. So indices are square numbers, cube numbers. It's anything with this little number up here, also called a power. So we solve whatever's in brackets first, then we scan through again and we look for any indices. We solve them. Then we look and we go, is there any division or multiplication? We can do these interchangeably because they are the opposites of each other. So is there any division or multiplication? Yeah, okay, I'll do that now. And then finally, I'm going to add or subtract my sum. So I think the best thing to do, if you do find a B.I.D.M.A.S style question, the best way to do it is to look and think, well, how many sums are there here? All right, I've got an addition, an indice, and I've got a bracket. So first of all, I've got to solve the bracket and then just rewrite it again underneath it, simpler. Okay, now I can make that simpler. I'm going to solve my indice. Then I'm going to look at the overall addition. So in regards to brackets, and this, we always solve brackets first, and there's just one or two things that we need to just be very comfortable with. A number outside the bracket means there is that many of the bracket. Again, it's a bit frustrating. In some countries, I know in Eastern European countries, I think even in France and Germany as well, you'll see instead of this multiplication sign, people tend to use a dot. So if they were to say, 3 multiplied by 5, it would be 3, a dot in the center, and then 5. And this would be like to demonstrate this multiplication. It's more useful because even with brackets, if we have 3 dot and then whatever's in the brackets, we know that this means multiply. Unfortunately, in England, it's that simple thing. We don't use a multiplication sign because we commonly use brackets in algebra. The multiplication symbol itself looks very similar to a letter X. It could cause confusion, and that's why we don't use it. So the main thing to know is if there is a number outside of a bracket, you have that much of everything inside it. So something like this. Okay, I've got 3 brackets 7 plus 3. Okay, using my B.I.D.M.A.S, I'm going to solve what's in the bracket first. 7 add 3 is 10. I've got 3 lots of 10. So I've got 30. Is that okay for everyone? Does that make sense so far with the brackets? Yeah. Okay, so that's really the only thing that we need to know in regards to brackets. We solve what's inside there first, and then if there's a number outside, it just means we are going to multiply it by. So the next thing, so that's our brackets. The next thing we need to be aware of is what's called indices and roots. It sounds very mathematical. Don't worry, we don't really have to deal with these very often. Indices are also called powers. It's this, again, we have a lot of synonyms in the English language. They are the exact same thing. It's like a little superscript in the top right. Most people have seen like the power of 2 before, and you might know that it means squared. So something here, 1 times 1 is 1, and we could also write that as 1 squared. 2 times 2 is 4. We could also write it as 2 squared. So that 2 value there just means you've got 2 lots of this number, or you've got this number multiplied by itself 2 times, sorry. Makes more sense with here. If we're dealing with square numbers, always just imagine that you're making a square. I've got a 3 by 3 square here. So 3 squared is going to be 9. Again, the common mistake is that people look at the 2 and they think, oh, you just multiply it by 2. What it means is that you're multiplying the number by itself that many times. So in this case, we're multiplying 3 by itself twice. 3 times 3. And then finally, we've got 4 squared, which is the exact same as 4 times 4. And that is going to be 16. It seems very strange. Why not just write 16? Why write this? One of the main ways is it actually saves space in the long run. And when we deal with in the scientific community as well, if we're dealing with very big numbers or very small numbers like Avogadro's number, when we're dealing with very small concentrations, it's a lot easier to write things with a superscript. In regards to something like with 10, I could write maybe 10 to the 30 like this. What that would mean is it's 10 multiplied by itself 30 times. So if you imagine if I had to write that number out every single time, I'd have to do 1 and then 30 zeros. I'm going to use a lot of paper. We want to save the planet. So, let's go with that. So square numbers, very, very common. We see them quite frequently. But again, these indices are not always just linked with square numbers. In regards to us, we will only really see square numbers, maybe a cube number. But just remember, the superscript is how many times that number is multiplied by itself. So again, in this case, we've got a cube number. So that means 1 times 1 times 1 is 1. 2 cubed, 2 times 2 times 2 is 8. And as you can see here, A cube with the dimensions of 2, so it's 2 long, 2 high, and 2 wide, 2 deep, will have 8 smaller cubes inside it. 3 cubed, 3 times 3 times 3, there are 27 smaller squares there. Imagine like a Rubik's cube, if you would. 4 cubed, that just means 4 times 4 times 4, 64. The notations do generally make things simpler, like I was just saying. The main thing with these, though, is that you will see squared and cubed units when we look at measurements. So when we deal with area, we look at squared, like centimeters squared, meters squared. You might see the indice in a sum, but it will just normally be a small 2. And all the examiner wants to know is that you are comfortable and able to, you know, that superscript there means that it is not just 2 lots of it, that it is a number multiplied by itself. Like I said before, everything in maths has an opposite. So the opposite of a square root, of a square, sorry, is a square root. We don't need to know about anything further than that, like cube roots or quad roots. We don't need to know. But just as a bit of an example, if I have, let's go with, we'll have 4 down here. Yeah, slightly bigger. Let's go 5. We've ignored him. Okay, so I've got 5. If I want to know, well, what is 5 squared? That is the exact same as saying 5 times 5. Exactly the same thing. And I can get that answer. I know, well, 5 times 5 or 5 squared is going to be 25. The opposite of this is called a square root. And it has popped up a few times, and they will only ever really, I've only ever seen them give whole numbers. So in this case, they might say, well, then what is the square root? And that's what it looks like. It looks like our bus stop, but it's got a little tail here. So what is the square root of 25? What I'm looking for is what number multiplied by itself equals this number. So how you can see here, so 5 squared, 5 times 5 is 25. And therefore the opposite of this would be the square root of 25, which is 5. So for us, again, you will only ever really have a squared number. That's all I've ever seen pop up before. But if by some chance you get like a cube number pop up, just remember it means, you know, 1 times 1 times 1. Or if it was 5 cubed, it'd be 5 times 5 times 5. So I hope that makes a bit of sense there. And we've already looked at our multiplying and dividing. So what I'll do now then is give you a couple of examples. I know this looks a bit more difficult, a bit more like, you know, a bit more algebraic, some would say. The main thing is, even this question here, so question 1, I've not seen a question this complex in the papers at all. So just bear that in mind. All you need to do, have a look at each step there and just simplify. Okay, so I've got 3 plus 7 squared plus 3 times 6. All you've got to do, and I'll write it down here for you, is just remember B.I.D.M.A.S. Look at the question, are there any brackets? Yes or no? Okay, is there any indices? Are there any square numbers? If yes, solve them first and simplify your answer. So 7 squared, okay, 7 times 7, 49. Just rewrite the sum with that answer in there. I'm going to give you guys a minute for this, and then I'm going to start going through. I'll go through the first one first of all, and then we can go from there. Andrea, I'll check that answer very quickly for you. Yeah, absolutely perfect. Yeah, you've clearly got an understanding of that. That's great. Okay, so have a go at a couple of these and pop your answers over when you're ready. Okay, lovely. We've got some answers coming in then. Okay, I'm going to start going through these then, just to give everyone a bit of an idea. But I'm liking what I'm seeing so far. Most people have got the same. If not, hopefully you'll be able to see where you might have gone a little bit wrong. And again, don't worry, making the mistakes is actually normally more beneficial. If you just understand stuff straight away, then it's very useful in all fairness. But if you make a mistake and then you correct yourself and you know why you've made the mistake, it will make more of a semantic link. It will make the memory a bit stronger. Okay, so let's have a look at some of these then, and we can obviously have a look and celebrate if we've got them right. If we haven't, it's a new thing, do not worry. So first of all then, I've got 3 plus 7 squared plus 3 times 2. Are there any brackets? No. What about an indice? Yes, there is. So I've got an indice there. So I've done this 7 squared is 49. And all I've done here is I've just simplified my sum from before. Normally I'll write this under my workings, but for this PowerPoint, it makes it easier. So I've now got this exact same thing can be written as this and simpler. The next step then is going to be saying, well, okay, what's next here? Is there any division? Nope. Any multiplication? Yes, I've got 3 times 2. I've got 3 lots of 2, and that's going to be 6. Finally, then, all I've got is addition here. If I add all these together, I'm going to end up with 58 as my answer here. Looking at our next problem then, so I've got 2 plus 6 bracket 3 plus 5. Are there any brackets? Yes. So the first thing I want to do is kind of zoom in what's in that bracket. Okay, I've got 3 plus 5 there. That's going to give me a total of 8. Great stuff. Yeah, Sarah, I think that one's right for the last one as well. I'll have to double check though. I'm liking this. So people, okay. So with our next one here. So what we've done then, we've done, okay, well, 3 plus 5 is 8. What we've got to remember here is that 6 outside the bracket means that there is 6 lots of everything inside the bracket. So 6 multiplied by 8 is our next step there. And that is going to give us our total of 48. And then finally, we have 48 add 2, which is going to be 50. So for our very last one then, we've got our 4 brackets, 3 squared times 2 plus 18. It looks a bit more complicated, but again, all we do is we look, first of all, are there any brackets? Yes, there are. It's almost like Inception, but with maths, like mathception. So we look in the bracket. Inside that bracket, we start B.I.D.M.A.S all over again. There might be another bracket inside the bracket. We don't know. In this case, in that bracket, there's an indice and a multiplication. The indice is higher up there, so I'm going to solve that first. So now I can rewrite this 3 squared, that is 3 times 3. Imagine a 3 by 3 square. How many smaller squares are there? We're going to have 9 there. And now I can look here and I can say, well, what's my next step then? Are there any brackets? Yes, there are. I've still got this bracket here. I need to solve it. I'm going to use multiplication then, because it's 9 times 2. And that's going to take me to this point here. So I've now got 9 times 2 is 18. I've now got 4 lots of 18, add 18. At this point then, the next step is going to be actually a multiplication. It's the number outside the bracket. Again, if there was a plus there, if it was 4 plus brackets 18, then you would treat it as a plus. If there is nothing there, no sign at all, then just remember it's always a multiply. So in this case, we've got 4 lots of 18, and that's going to be 72. And then we're going to add that 18 on there to get 90 in total. Yeah, no way. I'm like that. Someone's just commenting again, like, what? It's been a really long day. Like, it's absolutely fine. I know it's even, I know a lot of you have probably been at work all day or other things. If it's starting to kind of just go over your head a little bit, don't worry about it. Just let it go. It's fine. We can recap this. We can review it. We've got a lot of time. In general, though, what I'm seeing there is, you know, the answers are all pretty much spot on. The majority of people have got them right. If you haven't, though, I'm hoping that shows where they've gone wrong or where the answers have gone a little bit. I know for some people, like for this one here, little mistakes, like maybe thinking it might be 16, for instance.
Yeah.
And it's just that simple thing of just thinking, oh, there's a 6 and 8, I'll put them together as 14, add the 2, sorted. The thing I'll just highlight very quickly is that these are considerably harder than anything you'll find in the exam. I've never seen anything even this complex in the exam. So don't worry, if you're getting the right answers or getting close to the answers there, you'll be fine. And it is a topic that really only pops up on the non-calculator paper. It is involved with our formula questions as well. So if we get given a formula, which we do commonly get for level 2, a formula for level 2, you might have to use a bit of B.I.D.M.A.S as well. But again, it's not too difficult. They're normally quite linear. How's everyone doing with that? Are we okay? Does that make sense? Kind of. I'll take the absolute silence as a yeah, absolutely fine. We got you. Oh, there we go. All good. I am aware at the time. I know it's been a bit of a long one today, but we've just got our last 2 little topics to look at, which is our work on decimals. So let's crack on, have a look at these, and then I can show you obviously where to go from here. So the main thing to look at here in regards to ordering decimals, I think the quickest way to look at this is I will just give you a question and I'll just ask you to submit what answer you think is the correct one. So if I have let's say 0.5 and I have 0.41, which one of these is the larger number? Is it 0.5 or 0.41? And one thing that's very helpful is to listen to how it's said, 0.41. So if you could just quickly message me and just tell me which one of these is larger, that will really help me kind of just make sure I'm addressing everything correctly here. Andrea, yeah, you are completely spot on. That's the right answer. Sarah, brilliant, yeah. Claire, Lewis, yeah. Brilliant stuff there. Okay, cool. Yeah, so there's one answer there which is a little bit different. Don't worry, it makes sense. What I'll do is I'll explain it in a way that makes a little bit more sense, and hopefully that will just cement this for everyone. So with this then, it's very common for people to look at this and think, well, 0.5 or 0.41. Well, 41's bigger, isn't it? So surely that should be the bigger fraction. The thing is here, what we've got to remember is even as we go into decimals, our biggest number is always on the left. You think about it, 100 is bigger than 10. 10 is bigger than 1. 1 is bigger than 0.1, and so on. So it's always the number on the far left, which is the largest. People can get a little bit confused sometimes. One thing that really helps with this is put on the extra zeros. If I put a 0 here, which I can quite simply, it doesn't change the value. It just tells me that there's nothing in that smallest column. Writing it like this can be very, very useful sometimes. So for some, you know, if you have something like 0.801, or you have 0.9, some people would be inclined to kind of say, oh, well, 0.801's got to be bigger because it's 801. It's not the case if we think, if I can put in these extra zeros here because I know there's nothing in this column and there's nothing here either. It can visually help you though, if this is something that you find a little bit confusing. Got another example here for you very quickly. So if we were, and again, you might be asked to compare these numbers, put them in order. Do remember, if you are asked this, to think about the context as well. Sometimes there was a question recently that was referring to whose time was fastest. So in that case, the smaller decimal is actually the better answer. Ah, cool, I'm liking that. There's already been some clarity there. That's brilliant. So with this then, if I wanted to compare these two numbers, I'm just going to start from the far left and I'm going to just work backwards with it. So in this case then, I'm going to start from 0 and then I'm going to move along to the right. So they've both got 0, they're both equal at this point. So if I move along them, the next number after the decimal point, they've both got a 4 there. So both of these numbers are the same up to this point. What I can then do, move a step further, and it's at this point here I can now say, hang on, they were fine before. The bottom number now has the bigger value in the same column, so that is going to be my bigger decimal. If I imagine it as just up to those 2 points, you've got 0.45, you've got 45p, or you've got 48p. So this one here at the bottom is going to be the greater value then. So in regards to ordering decimals, that's all I wanted to really do. Have a very quick look at that. The majority of answers there were all absolutely spot on. It is quite common to have a little bit of a kind of a think about it and be like, okay, well, it's 41. Just remember, after the decimal, it'll be 0.38 or 0.72. It's not 72. Okay, we've got our last topic, and then I'm done, and I'll stop talking. I promise. So, rounding decimals then. In functional skills, we need to be able to round decimals to up to 3 places. Commonly, it'll be 1 or 2. There have been examples with 3. Doesn't mean it's any more difficult. It's the exact same thing. Once we know how to do this skill, we are sorted. The reason that we do this, so we round numbers to make them simpler and easier to work with. And that's why we round to only our desired level of accuracy. What I mean by that is, let's say we have pi, for instance. So pi is not a 0 there. That's completely wrong. Good work, Tom. So pi is 3.14. And what that is it's been rounded to that value, 3.14. This is the value that you'll use if you have any circle problems, if you're a level 2 learner, and they always ask you to use this value. Now, pi itself is a value that goes on forever. So it's a non-terminating decimal, which means all the numbers after it, I know these two, I don't know any more. There are people who can remember it to like 9,000 places and they get given money for that, which is great. But at this point here, I could just make up this number and it can go on forever and ever and ever. But if I imagine, like, if I was, let's say this is now like a weight. If I was weighing out some ingredients to make a cake, I don't need to know that if I use exactly 3.1415178 grams, I'll get the perfect cake. I'm quite happy to say it's 3 or maybe 3.1. We use rounding just to get our answers to an acceptable point. And again, if you're in the scientific community, if you're doing some science at college or university, they will tend to give you like a value to round to. 3 decimal places is quite accurate. Sometimes it will go further. So the idea with rounding then is we only ever look at the number next to the one that we're rounding from. As one more quick example, we find sometimes if we're rounding, so let's say I've got 7. Let's go with 4. Five. Again, this number is very, very long. If I'm rounding this to 1 decimal place, or we can even say to the nearest whole number, the idea is that I'm saving time. So what we're going to do here is let's say I'm rounding to the nearest whole number. I'm only going to look at the next number. So I'm going to say, all right, well, 7.44445. Right, what to the nearest whole number? Right, 7.4. Is it closer to 7 or closer to 8? That's all I'm doing. I'm not going to go all the way back here and say, well, 5 will make this become a 5, and that will make this become a 5, and this become a 5. You'll get more of this in the next example, but we only work with the value next to the one that we want to use because we are trying to save time. We'll look at the main concept, which is rounding. The other thing that you need to be aware of is something called logical rounding, and we'll have a quick look at that in a second as well. So as an example then, we've got this number here, and we have got, so the question we're being asked is round 6.752 to 1 decimal place or to 2 decimal places. So in our exam, we're not going to be asked that specifically, but it might say, give your answer to 1 decimal place. All we have to do is work out where is the first decimal place. Some of you might know it as a tenth or a hundredth or a thousandth after the decimal, but basically the first number or the first value after the decimal is the first decimal place. Then there's the second decimal place, the third decimal place, and so on. So for this one here, Andrea, you're absolutely spot on. With this, all I'm going to do is I'm going to look here, I'm going to go, right, where's the first decimal place? There it is, it's the 7. I'm going to draw a line down there next to it. The other numbers, I'm not really going to need to worry too much about. In this case then, so this is my first decimal place, this value here. When we round, again, with most people, if you think of rounding to the nearest 10, the nearest 100, most people are okay with the high 5 rule. In maths, if the value is 5 or greater, we round upwards. If it's under 5, we leave the value the same. So if I had £14 to the closest 10, it would be 10. However, if it was £15 to the nearest 10, I'm going to be optimistic. I'm like, yeah, cool. I've nearly got £20. So that's the difference. If it's 5 or higher, then it rounds upwards. So in this case here, then, what we're going to be looking at is the next number along, which is the 5. We're not going to look at any other numbers. This number could have 50 numbers after it. Doesn't matter. I'm not going to look all the way to the end. It is a waste of time. I'm simplifying it. So I've got 6.75. The 5 is 5 or higher. So that will make the 7 round up to 6.8. Same type of question. If I was rounding to 2 decimal places, I do the exact same thing. I just look there and I go, well, where is the second decimal place? It's there. It's the 5. The 5 is the second decimal place. I look at the one number next to it, which is in this case is a 2. Does that 2 make the 5 round up or stay the same? In this case, it's going to stay the same there. How is that for everyone? Does that make sense? Are you okay to try a couple of these?
Yeah.
Yep. Awesome. Awesome.
Yeah, I think so.
Yeah, I know it's been a long one as well. So if you do get 1 or 2 wrong, then don't worry. Lewis, not a problem. The assessments will be on the classroom. It is the non-calculator, so unit 1 assessment that we need to do, and the decimals assessment as well. So if you can get both of them done for me, that'd be great. For next week, obviously. Okay, so very quickly then, here are a couple of practice questions. Given the time, do we want to practice 1 or 2 of these, or are people quite happy to move on? Okay, let's just take a minute or 2 then. Just try the first question there. So 10.615. Try and write that to 1 decimal place, and try and write it to 2 decimal places. And then if you have time, try 1 or 2 others, and we'll go through a few of the answers together. Andrea, yeah, you obviously don't have any problem with this, which is brilliant. Sarah, the first one, absolutely fine. Second one, just remember the 5 is going to impact that 1. So you've located the second decimal place. You just need to remember that the 5 is going to make that round up, so it will become a 2. Andrea, yeah, brilliant again. Yeah, that's spot on for the next one. And yeah, again, it's a good one to look at, that one, because it's the idea of the 9 value being there. So I will address that. The great thing is with that 0, you don't actually need to keep the 0 on there. In functional skills, you're not going to lose a mark there. I have seen it in some GCSE exams though, where people have actually been docked a mark for putting the extra 0 in. Just examiners being a bit horrible, really. Okay, what I'm going to do for everyone then is just I'm going to go through a few of these just quickly, just to highlight what the answer is going to be and why, and then we're going to kind of leave it there, and we'll have a very quick look at our logical rounding, and then that is our session complete. So at this point here then, so we've got our first answer here is going to be 10.6. The 6 is our first decimal place. We look at the 1 number next to it, which is the 1. If we imagine if that was 61, what's it closer to, 60 or 70? Yeah, it's going to be just the 6 there. To 2 decimal places then, I'm now looking at the 1 value. I just want to be left with 2 numbers after my decimal. That's it. All the rest of them I'm going to get rid of. I don't need to know it that specifically. In this case, I'm going to end up with 10.62. The reason being that 5 is going to make the 1 round upwards. So the other example I want to do is just have a look at this next one. So first of all, we have 3.7. Hopefully people are quite happy with this as an idea.
Mm-hmm.
My first decimal place is here. The 9 is going to round that up to a 7. So I've got no problem there. Now, as rounding this to 2 decimal places, I get 3.70. And again, technically, that 0 on the end is not needed. But again, we're not going to lose the mark for putting it there. The reason this happens is, again, imagine it's that carry-on kind of system. We have up to 9 in each column. When it becomes 10, it moves a column. So in this case, the 9 is our second decimal point. The 8 is going to make that round upwards. What's 1 greater than 9? Well, it becomes 10. So therefore, this will become a 0, and the 1 moves to the column next door and becomes 7. Does that make sense to everyone? Is that okay?
Yes.
Yeah.
I'm not here. Yes. I've had enough of maths. So. Okay, absolutely brilliant. Okay, if you're not too sure, don't worry about it too much. It's one of those skills, it will pop up frequently as we move on through the course as well. Do remember that we're going to have a whole week to obviously complete these assessments and to recap this skill in particular. If it doesn't make too much sense, don't worry about it. Think of all the other things from this session that do make sense. You know, we'll try and stay positive about this. I'll just quickly nip through one more then. So this last one here, if I'm rounding this to 1 decimal place, that's what I'm going to be left with. You could almost, if it helps, imagine your 2 options. Okay, if I'm going to 1 decimal place, it's either going to be 18.4 or it will be 18.5. Those are the only 2 values it can be. Okay, now I'm going to draw that line in there. I'm going to look, right, does this 1, is that 5 or higher? No. My answer then is going to be 18.4. For the next one as well, you know, so to 2 decimal places, that's where I'm going to draw my line. It's going to have 2 decimal places. The 1 there, it's either going to be 18.41 or it will be 18.42. I look at my next value, this 2, is that going to impact it? No, it's not. 18.41 will be the answer. You can look at this. Some people find it a bit easier to almost like locate where the decimal point is and then ignore it. You know, I know where the second decimal point is. I'm going to look at it as a whole number and say I'm rounding it to the nearest. In this case, it'd be the nearest 100 and the nearest 1,000. Some people find that easier. The skill itself, this does get really commonly confused with multiplying and dividing by 10. A lot of people, when they're asked to round to 1 decimal place, they move the decimal point and they make the number bigger or smaller. It's quite a common thing. Obviously, I think most people are doing quite all right in this case. So let's just check that last answer. Yeah, Stacey, they're absolutely spot on for the next one. That's brilliant. Hooray! Okay, fantastic. So what we're going to do then, we're going to put a pin in it there, because it has been quite a long session with a lot of different content covered. Here are all the answers. So if you do want to practice this, just work through the PowerPoint on your own. You've got that. You've also got the recording, and you can actually pause me in real life so I don't talk so much, and you can have a bit of a breather from me. The last thing I'm going to say, last slide here, is about when we use what's called logical rounding. Normally, we always use rounding unless it's in a certain context. So during the working out stages of your calculations, what I would say is only round at the end of the question if you're asked to. If they say give your answer to 3 decimal places at the end of the question, then any kind of workings out on your calculator, I would keep it up to at least 3 or 4 decimal places, or just leave the whole value on the calculator and just click add, and it will remember the whole number. So only round at the end, because if you round sooner, those little numbers can make a bit more of a difference. The main thing we've got is this idea of logical rounding. Doesn't follow this conventional high 5 rule, but it's very easy to understand because it's a real life problem. If we imagine, let's say we're trying to work out how many tins of paint Barry's going to need. If we calculate it perfectly and we work out, right, he needs exactly 2.4 tins of paint to paint his room. The problem that you've got is that you can't go into a shop and go, excuse me, sir, may I have 0.4 tins of paint? Because they'll just go, no. There's also the fact that in real life, if Barry's going to be painting that, he might accidentally knock over the tin. He might have to repaint a bit because he lent on it. And again, it's what garages are for. You're supposed to have half-empty tins of paint stashed in your garage for no apparent reason. The main thing here is that with logical rounding problems, even if it's 0.4, so in this case, it should round down, you need to have an excess. And again, it works differently in regards to if you think how many people can fit in this space. 15.9 people can fit in here. You can't have 0.9 of a person. You're just going to have to say, I'm sorry, it's 15 people. That's the maximum capacity. So logical rounding problems, sometimes you'll go through, you'll calculate something and it comes out as, you know, how many tins of paint or how many packs of bricks does this person need? My answer is 3.17292. I can't get that, so I need 4 packs. And that's actually going to get you an extra mark. So that's always a really nice thing there. Okay, so the topics this session then, what we've looked at answer checks and estimates. We know that when we do an answer check, we just do our sum backwards. The sign will change, the numbers will stay the same. It's a good way to check our answers. We know about our opposites now. We've now all got a method for long multiplication. We can use the grid method, and we know how to multiply with decimals. We can remove the decimal points, and then we can either use an estimate or our knowledge of multiplying by tens and hundreds or dividing by tens and hundreds to get our answer. We've now all got a system for long division. We know how to use the bus stop method and when to implement this, and how this is also affected if we have 2 decimals in our numbers. We've looked at negative numbers and how we can visualize this, maybe thinking about temperature and thinking, is it becoming more or less positive? Always a good way to kind of consider it. We've then looked at our B.I.D.M.A.S, our order of operations, why we use this and what kind of questions commonly pop up about it. And again, the level that we've looked at in here is considerably higher. When you have a look at the assessments, all of the questions have been taken from past exams, and you'll look at them and you'll be, it's literally just one, it's like 160 plus 5 squared is, I think that was on a level 2 paper. Very, very short, very simple, very sweet. We then had a look at ordering decimals and a bit about decimal theory, about everything going up in units of 10. So the biggest value always being on the left, regardless of how long the number is. And we've looked at our rounding decimals. So at this point then, I'm going to stop the recording there. The assessments for this classroom or for this this recording are the non-calculator assessments and the decimal assessments. This topic, we've covered 2 of the units on the classroom. So if you are watching this later, then do feel free to have a go at those assessments at this point. So yeah, so that's the end of the recording. Let me just stop that there. How do I stop it?